On one large campus, 18% of students surveyed said that they spend less than 1 hour per night studying. If 3 students are picked at random, what's the probability that all 3 spend less than an hour at night studying? So let's address that part of the question first. So we're picking 3 students and we want to find the probability that all 3 spend less than an hour studying. So we're finding the probability that the first spends less than an hour and the second spends less than an hour and the third also spends less than an hour studying. When we then split up these probabilities, we actually have 3 different events with and. So this is something where it's not an or question, all 3 have to spend less than an hour studying. So when we have and, we want to find the product of these separate probabilities. So we want to find the probability that the first multiplied by the probability that the second multiplied by the probability that the third spends less than an hour studying. From the problem, we know that there's an 18% chance that students spend less than an hour studying. So we're going to find the product of 0.18 times 0.18 times 0.18. When you have a repeated probability like this and you're finding the product, a shortcut is to use an exponent. So you could do 0.18 to the third power. So this is approximately 0.0058. Or if you represented it as a percentage, it's a 0.58% chance that when we select 3 students, all 3 will spend less than an hour studying. So a couple of things that will help you are the number of people that you're selecting is going to match up with the number of separate probabilities that you're going to need to set up. So if we are picking 3 students in this situation, then we're going to have 3 separate probabilities. Now let's look at the second question. So now, what is the probability that 2 of the 3 do? Now the way this is worded really changes the concept of the overall probability here. So let's talk about the different outcomes that can occur if 2 of the 3 spend less than an hour studying. So one outcome is the first spends less than an hour studying and the second spends less than an hour studying, and now the third student, because remember we are picking 3 people, so it says 2 of the 3. So we could have the first one be less and the second be less and the third would then be more. Or another outcome, so each student actually is a separate event. Another outcome is that the first is less and the second is more than an hour studying and the third is less. So see, this is shifting it. So this is a totally different event. The first is less, the third is less, but the second is more. So we still have 2 out of 3, but it's a different event because the second person is a different person. Okay, the third way that this could happen is that the first spends more than an hour studying and the second spends more. So we got less, oh no, the second spends less and the third spends less. Okay, so this is probability that 2 of the 3 spend less than an hour studying. So still have 2 of the 3 spend less than an hour studying, but this is the new event because in this case the first person spends more than an hour studying. Okay, and this is an or situation as well. So it's kind of like we have these individual outcomes we're listing, and this is all of the different things that can happen. I've got 1, 2, and 3. And the first whole event could happen, or the second could happen and this would still work, or the third could still happen and this would be a probability. So now let's look at these different events. The probability that the first is less up here is 0.18. probability that the second is less is 0.18. Now the complement of 0.18 would be you subtract it from 1. So 1 minus 0.18 is going to give you 0.82. So the probability that a student spends more than an hour studying is going to be an 82% chance. Because this individual event outcome is a and, you're going to find the product of these. So you're going to have 0.18 times 0.18 times 0.82. And that is equal to 0.026568. Now let's look at outcome 2. The first is less is 0.18. The second is more is 0.82. The third is less is 0.18. Because it's an and, we multiply again. 0.18 times 0.82 times 0.18 is going to give me again 0.026568. Third event. First is more, so that's 0.82, and second is less, so that's 0.18, and third is less, that's 0.18. So you find this product, and again, it's the same three numbers that you're multiplying. You're going to get the same product, 0.026568. Okay, so I found the probabilities of these separate events. Now, the probability that 2 of the 3 do means this could happen, or this could happen, or this could happen. These are all the ways that 2 out of 3 students spend less than an hour studying. Now, or means add. So my final overall probability is the sum of these 3 answers, 0.026568 added together 3 times. So this equals 0.079704. That rounds, if you round to the nearest hundredth position, to 0.080. And that is the answer that we have for the solutions here. Now the solutions do represent it in a different format, but the math is really the same. They multiplied by 3, and so I want you to see where that's coming from. They showed let's look at this on a different page. So they showed 3 times 0.18 times 0.18 times 0.82 equals approximately 0.080. Well, when I listed out my 3 different events, notice that I had the order of these different. So I had 0.18, 0.18, 0.82, and then the 0.82 is moving around depending on my position of my people. Okay, but these are all the same probability, so the order of these numbers does not matter. So this is okay here. Now why do they multiply by 3? Well, remember, each time I got the same answer. And because it was an or, I was adding those answers together to get my 0.079704. Well, a shortcut, if you're adding the same number multiple times, is to find the product. So if I don't want to type this number in 3 times and add it, I can just do 3 times 0.026568. Or they just did 3 times the product. Same thing, and you get the same answer.